Hello everyone. In this video, we are going to solve the problem number 1.68 from Irodov, and that is related to dynamics. So let us first understand the problem and then we will solve the problem step by step. So at the time moment of t is equal to 0, the force F is equal to at is applied to a small body of mass m, which is resting on a smooth horizontal plane where a is constant. This particular a is constant. The permanent direction of this force forms an angle of alpha with the horizontal, and we have to find out the velocity of the body at the moment of its breaking of the plane. Breaking of the plane means when it is leaving this particular surface, and at that particular instant the normal reaction will be 0. So let us first draw the free body diagram of mass m. So we will have the gravitational force in the downward direction, that is m into g, and we will have the normal reaction in the upward direction. And if we take the component of this force in the horizontal and vertical direction, then we can denote it as F cos of alpha in the horizontal direction and F of sin alpha in the vertical direction. Now if the body is moving with the acceleration of a, then, or let us denote it by w, because a is used in this particular expression where it is constant. So we can write in the horizontal direction, that is F cos of alpha is equal to mass into acceleration. So this is our first expression. If we talk about the forces in the vertical direction, if it is making an angle, the contact with the surface, that means it is not moving in the vertical direction, so there is no acceleration in the vertical direction. In that case, we can just balance the forces in the upward and downward direction. So we can write n plus F sin of alpha is equal to m into g. So from here we can write n is equal to mg minus f sin alpha. Let us substitute the value of f is equal to a into t. So from here we can get at cos of alpha is equal to mass into acceleration, and from here we can get n is equal to mg minus at sin alpha. So this is our second equation. Now if we carefully look at here, as the time is increasing, okay, the acceleration will also increase, and in this particular case, as time is increasing, this particular quantity is increasing, as we are subtracting this particular term from a constant term, that is mg, so overall term is actually decreasing. So as time is increasing, normal force is actually decreasing, and when it will decrease it to 0, then we have to find out the velocity of the body in the horizontal direction. Okay, so let us say n is equal to 0. At that time moment we can write mg minus at sin alpha is equal to 0, and from here we can write t is equal to mg divided by a sin alpha. So this is the time moment at which it is breaking off the plane. Okay, now let us focus on equation 1. So we can write at cos of alpha is equal to mass into acceleration, and we have to find out the velocity. For that acceleration we can write it as dv upon dt. So from here we can get dv upon dt is equal to a cos of alpha whole divided by m into t. Let us take dt to this particular side, and we will get dv is equal to a cos of alpha whole divided by m into t times dt. Let us integrate both the sides from v is equal to 0, because it is starting with at t is equal to 0, to let us say v, and t we have obtained, that is mg divided by a sin of alpha. The differentiation of 1 will be v, so we can write v from v is equal to 0 to v, that is equal to a cos of alpha divided by m, and the integration of t is t square by 2 from t is equal to 0 to t is equal to mg divided by a sin of alpha. So from here we can get velocity is equal to a cos of alpha whole divided by m into t square by 2 and t is equal to 0 to t is equal to mg divided by a sine alpha. Let us substitute the value of t and we will get v is equal to a cos of alpha divided by 2m into m square g square whole divided by a square sine square alpha minus 0. So from here we will get velocity is equal to a cos of alpha into m square g square whole divided by 2a square sine square alpha. So from here finally we will get velocity is equal to cos of alpha into m times g square m square g square, here m is also there, so mg square whole divided by 2 times a sine square alpha. So this is the expression of velocity we got. Okay, now in the second part of this problem it is asking to find the distance traversed by the body up to this particular moment. So we have already obtained the velocity as a function of time, that is v is equal to, from here we can say it is a cos alpha upon m into t square by 2 a cos alpha upon 2m into t square, and we can write velocity is equal to derivative of the displacement with respect to time, so that is equal to a cos alpha upon 2m into t square. Let us take dt to this particular side and we will get ds is equal to a cos of alpha divided by 2m into t square into dt. Let us integrate both the sides from s is equal to 0 at the time moment of t is equal to 0 to s at the time moment of t is equal to mg upon a sine alpha, where it is breaking off from the plane, so mg upon a sine alpha. So t is equal to mg upon a sine of alpha. The derivative of 1 is s, from s is equal to 0 to s, that is equal to a cos of alpha divided by 2m, and the integration of t square is t cube by 3 from t is equal to 0 to t is equal to mg divided by a sine of alpha. So from here we will get s is equal to a cos of alpha whole divided by 2m into 1 upon 3 times m cube g cube whole divided by a cube sine cube alpha. Okay, so from here we will get s is equal to m cube g cube into cos of alpha whole divided by 6m into a square sine cube alpha, or we can write s is equal to m square g cube cos alpha whole divided by 6 times a square sine cube alpha. So this is the expression of distance we got till the time moment of t is equal to mg upon a sine alpha, where the body mass m is breaking off the plane. Okay, and we have also find out the velocity at the time moment of t is equal to mg upon a sine alpha. I hope the entire procedure is clear. Thank you.